formal properties of true narrative representations can quantum entanglement be explained as the abstract and concrete connectedness of TNRs. Ordinary perceptions and experience or perceptions of the outcome of an experiment are all TNRs. For instance, suppose you flip a coin. Came up heads. In this diagram, let S pi O represent the symbol, the pi mapping of that symbol onto the object situation, which is the flipping of the coin that comes up heads. It's a true narrative representation because all of these elements come into agreement. Or we can think of another pragmatic mapping relation where the messenger RNA goes out into the cell, finds an amino acid, brings it back to the RNA, and verifies that it's collected the correct amino acid. It turns out that everything in probability theory and everything in the sciences comes down to what Magorov called the difference between a 0 and a 1. Everything in probability theory comes down to that. Boolean algebra comes down to that. Quantum entanglement comes down to the difference between a 0 and a 1. Well, for this presentation, I'm going to represent you as the 1 and me as the 0. If you take 0 away from 1, you still get 1. If you add 0 to 1, you still have 1. So let's say 1 represents you, 0 represents me. Now let's also say that the probability of a true narrative representation is 100%, or we'll represent it with 1 as contrasted with 0, which is the probability that a true narrative representation is false. If, for example, I say heads when the coin shows heads, then that's a true representation. And the probability of it being false is exactly 0 because of the connectedness of true narratives. Here's what I'm suggesting for your consideration. The result of every valid perception, every replicable experiment in the sciences, every interpreted result is taken to be a physical law. In fact, every discovery in the sciences, from Galileo to Einstein and Bohr, is completely dependent upon one or more TNRs. Only TNRs can determine experimental results. What's under the microscope? In sum, everything we know from experience, from empirical science, from perceptions grounded in the material world, all of our valid information about ourselves and the material reality of the world, whatever these may turn out to be, can only be determined by TNRs. A lot can be learned from well-designed experiments, especially ones that get intelligible, replicable results. Still pictures are dandy, but well-designed experiments moving across time are better. So Galileo dropped some cannonballs or rocks or something off of the Leaning Tower of Pisa. Aristotle predicted this result. Galileo predicted this one. Which one did we get? Well, here's a replication of Galileo's experiment, and I'm just going to play that. We're looking into the world's biggest vacuum chamber. It's owned by NASA near Cleveland, Ohio. Journalist Brian Cox is visiting this location, and they've set up an experiment to test Aristotle's theory. A heavier entity will fall faster than a lighter one. So we're testing, in this case, a bowling ball against feathers. They're about ready to make the drop. Here they go. The bowling ball falling and the feathers falling at exactly the same rate through 5 stories of space. No air in here to hold the feathers back, so they fall at the same rate. Watch these guys now. They can't believe their own. Scale matters, and things are different at different scales. In experimental determinations of what is true, scale counts a whole bunch. At the level of the cell nucleus, where we find DNA protected inside the very center of the nucleus, outside of it in the endoplasmic reticulum, where the DNA and the RNA interact with each other and with proteins through the ribosome, we meet up with Michael Behe's irreducible complexity. Pellegrini showed in his Decade of the Fractal Gene, genomic communications have a fractal patterning. And in 1981, I published this article about linguistic problems for evolution. Irreducible complexity is the quintessential clinching argument in that discussion. It was Michael Denton in his book Evolution of Theory in Crisis. He has a PhD in biochemistry and had been an evolutionist for many years, but when he started looking under the microscope, he discovered that he didn't really believe that theory anymore. His problem was essentially irreducible complexity. I also defined in 2013 what I called pragmatic information. Now, I'm only mentioning this because there's a progression here, and pragmatic information transcends the sort that Shannon had in mind and brings the real world into perspective. In the sciences, the ability to see smaller and smaller scales of the material world led to some remarkable theoretical perspective changes.
I remember the first time I looked in a biochemistry textbook and I saw a drawing of something called a bacterial flagellum. I looked at that and I said, that's an outboard motor.
These machines, some of them are running at 100,000 RPMs.
And even though they're spinning that fast, they can stop on a dime. It only takes a quarter turn for them to stop and shift directions and start spinning 100,000 RPM in the other direction.
The bacterial flagellum, 2 gears, forward and reverse, water-cooled, proton motive force. It has a stator, it has a rotor, it has a U-joint, it has a drive shaft, it has a propeller, and they function.
Since its discovery, scientists have tried to understand how a rotary motor could have arisen through natural selection.
Irreducible complexity was coined by Mike Behe in describing these molecular machines. Basically what it says is that you have multi-component parts to any given organelle or system in a cell, all of which are necessary for function. That is, if you remove one part, you lose function of that system.
Proteins do pretty much all of the jobs inside of the cell, except for storing genetic information. That's left to the DNA, the RNA. But all the day-to-day jobs, cleaning up the cell, making energy, it's all proteins.
The individual parts of a bacterial motor, like this ring structure, are each made of either a single protein molecule or an assembly of proteins fitted together into a specific shape.
You see of architecture down in the cell units in these protein-forming amino acids.
Alphabetic letters can be arranged in a huge number of possible combinations, and it's the sequential arrangement of the letters that determines whether you have meaningful words and sentences. If the letters are arranged correctly, you'll get meaningful text. But if they're not arranged correctly, you'll get gibberish. And the same principle applies for amino acids and proteins.
They are arranged, like letters, to form chains, often hundreds of units long.
Proteins are arranged with their amino acids in such a way that the amino acids collapse on each other into an architecture that is pre-programmed by the order of the amino acids.
The function of the whole depends upon the precise arrangement of the individual parts.
But what produces the precise sequencing of amino acids that gives rise to the specific shapes and functions of proteins? In his book, Biochemical Predestination, Kenyon and his co-author, Gary Steinman, proposed life might have been biochemically predestined by the properties of attraction that exist between its chemical parts, particularly between amino acids in proteins. The instructions necessary to assemble amino acids into proteins are conveyed by the sequences of chemicals arranged along the spine of the DNA. Kenyon was forced to confront the absolute necessity of genetic information.
Then I really had to reassess my whole position regarding origins. So the concept of the intelligent design of life was immensely attractive to me and made a great deal of sense, as it very closely matched the multiple discoveries in molecular biology.
After entering the heart of the cell, we see the tightly wound strands of DNA, storehouses for the instructions necessary to build every protein in an organism. In a process known as transcription, a molecular machine first unwinds a section of the DNA helix to expose the genetic instructions needed to assemble a specific protein molecule. Another machine then copies these instructions to form a molecule known as messenger RNA. When transcription is complete, the slender RNA strand carries the genetic information through the nuclear pore complex. The messenger RNA strand is directed to a two-part molecular factory called a ribosome. The process of translation begins. Inside the ribosome, a molecular assembly line builds a specifically sequenced chain of amino acids. These amino acids are transported from other parts of the cell and then linked into chains often hundreds of units long. Their sequential arrangement determines the type of protein manufactured. It is moved from the ribosome to a barrel-shaped machine that helps fold it into the precise shape critical to its function. After the chain is folded into a protein, it is then released and shepherded by another molecular machine to the exact location where it is needed.
This is absolutely mind-boggling to perceive at this scale of size such a finely tuned apparatus, a device that bears the marks of intelligent design and manufacture. And it's exactly this new realm of molecular genetics where we see the most compelling evidence of design on the Earth.
Since the late 19th century, since the time of Darwin, scientists came to accept a convention that excluded the possibility of design as a scientific explanation. It's called methodological naturalism, and it just means that if you're going to be scientific, you must limit yourself to explanations that invoke only natural causes. You can't invoke intelligence as a cause. And yet, curiously, we make inferences to intelligence all the time. It's part of our ordinary reasoning to recognize the effects of intelligence.
No one would attribute the shapes and arrangements of these symbols to natural causes like sandstorms or erosion. Human beings correctly detect the activity of intelligence whenever they observe a highly improbable object or event that also matches a recognizable pattern.
If you travel through the West, you'll see lots of different shapes on mountainsides. But what you don't see are the faces of Lincoln, Jefferson, Teddy Roosevelt, and George Washington.
RNA correctly translated to a protein is a TNR. Bearing in mind the problems being created by synthetic messenger RNA, also bearing in mind the research of Brody, Kyrie, and others about the lies being told in the media, it's worth noting that every valid pi mapping of the intended amino acid, we have a TNR. The synthetic messenger RNA in COVID injectables, however, is a lie in every instance. But consider what happens in the instance of the gold standard TNR. From inside the ribosome, the RNA text calls for a sequence of amino acids one at a time. The amino is mapped through messenger RNA to the symbolic RNA. The construction takes time, but the connectedness, once it's established, is timeless. It is the very essence, I suggest, of what physicists are calling quantum entanglement.
Meaning, in the sense of material content, information about the real world can only be discovered through TNRs. Here's a summary of the proof. Take any instance that you like of a TNR, say a coin toss or an experimental outcome reported truthfully, a genome that's registered and interpreted successfully from conception to maturity. Successful reproduction across generations provide many instances of TNRs. All these are TNRs. But we can systematically degenerate any TNR by removing its object or part of that object so that the interpreter has to imagine the missing part. In doing that, we derive the form of all fictions. If I ask you to imagine my flipping of a coin that comes up heads, you must imagine the coin and all the rest. You have to supply the object. A gene not turned on is a fiction, a possibility with one or many hypothetical proteins, say, as its imaginary object. Errors are even more complicated and farther removed from TNRs. In an error, two components are imperfect. The object is imperfect. It's not indicated by the sort of signal that ought to be used. For instance, if we say heads when tails is showing on the coin, the material fact is not the one indicated. But at the same time, if I say tails when the coin shows heads, the string of symbols is also imperfect. So an error is always imperfect in two of the parts of a TNR. In every error, there's a double information loss. In genetics, errors can be caused by various factors such as toxicants, radiation, electromagnetic interference, and they all tend to produce disorders, diseases, and sometimes death. Next, consider lies. In a lie, suppose O.J. was in L.A. killing Nicole, not in Chicago as he claimed. The object, the sign, and also the linking are corrupted in such an example. In genetic systems, it's possible for pathogens such as certain viruses and perhaps prions to deceive some of the self cells and the immune defense system. So lies, too, are involved in autoimmune disorders. Further corruption can be achieved by scrambling a string of signs or otherwise distorting the symbols to make any possible meaning obscure or to make it completely inaccessible. Further corruption is possible by just completely erasing the sign. Between the limits of an erased sign and a TNR, there is an actual physical loss of information at each transition, per proofs that were introduced many years ago by Edwin Thompson Janes. He showed that irreversibility is not merely a loss of human information, but an experimental fact. We can get from TNRs to all the other signs to the extent that they have any material meaning, but we cannot go in the other direction. To intuitively see that the proof is complete, we need a couple more steps. Imagine a string of symbols, S sub u, of unknown meaning, say in a foreign language or any language not yet deciphered. How will a child or a geneticist or a cryptologist discover the meaning of that symbol string? If we're given a TNR applied in the normal conventional way, discovering the meaning of the string is possible by using the object as a scaffold to climb up on and to supply the abstract meaning of the symbol. But what about using a fiction or an error or a lie or a scrambled string or distorted string that's meaningless or a complete absence of a string to guess the meaning of S sub u? Details aside, it's not possible to do that precisely because S sub u can't be used as a scaffold to build the meaning of the fictional part that has to be imagined because we don't know the meaning of S sub u. That's why it's called an unknown symbol or a string of unknown meaning. Therefore, the proof is complete because the irreversibility holds at every step of the derivation from TNRs on the one hand through fictions, errors, lies, scrambled nonsense, and complete absence of a sign. If the three elements are in agreement, the whole is a TNR. If the fact delivers all that the indexical use of the conventional sign requires, then the whole relation is a TNR. We can say, however, that the material fact is determined by the pi mapping of a string of symbols that signifies that fact. Such a structure found in every TNR and only in TNRs has this extraordinary logical uniqueness. It's the only kind of meaningful representation that can determine any particular fact out of all the possible facts in the universe. Also, the TNR relation establishes a connection between the fact it determines and all the other facts with which it's intrinsically related, including the pi mapping act and the string of symbols, so the TNR itself also has the unique logical property of a kind of balanced and well-determined connectedness with the space-time and material world. Finally, the symbol string appearing in any TNR is always generalizable across all possible material contexts up to the limit of complete sameness or identity. Why is all this important to genetics, epigenetics, and proteomics? Because everything there also depends on TNRs.
The underlying relationships in living organisms are completely dependent on valid TNRs. DNA, for example, communicates through RNA to proteins which communicate back to the DNA. And the DNA communicates also within itself, as RNA does, and as proteins also do. We discover, moreover, that there's an abstract and general way of looking at the underlying connectedness relations which are instantaneous and fractal, as suggested by Pelianes. To show how TNR theory applies in the abstract sense, we have a symbol mapped through action, pi mapping, into an object situation which is connected back with the symbol in such a manner as to make all of these relationships stand in agreement. And when that is the case, it also happens that the symbol, in communicating with the pi mapping, has a symbol pi, an S-pi-O relationship within it, and the S-pi-O relationship within the symbol communicating within itself is also an S-pi-O relation, and we can find relations within relations within relations. It was Einstein, it seems, who first saw that Bohr's equations required spooky action at a distance. Is it confusion that we're seeing? I think not. I think what we're seeing is simplicity comprehensiveness, and consistency. The connectedness that we're perceiving in experience, that's apt to get a whole lot more exciting very soon with quantum computing, because it apparently can come through nanoengineering right into our own bodies, as our colleague, the Israeli scientist Shimon Yanowitz, is exploring. With that in mind, I want to play this narrative I've extracted from a NOVA presentation about the Einstein paradox.
We live in a world where objects have permanence, and we see cause, then effect. But a startling phenomenon is revealing that this is not how the universe works at the smallest scales of atoms and tiny particles. Albert Einstein argued, it couldn't possibly be real. It makes a very troubling prediction called quantum entanglement. Nature's fundamental building blocks could be connected and influence each other instantaneously, as if the space between them doesn't exist. As if two objects can mirror each other without any apparent connection. Einstein called it spooky action at a distance. He rejected the idea and tried to prove it couldn't be real. Do we live in Einstein's universe of common sense laws? Or a bizarre quantum reality that allows spooky connections across space and time? "300 miles off the coast of West Africa, on one of the Canary Islands, a team of physicists is setting up a remarkable experiment that will use almost the entire breadth of the universe. Leading the team is Anton Zeilinger.
So we are now going up the mountain towards the Roque de los Muchachos.
The question goes back to Clauser and Friedman's Bell test experiment. In the years after their pioneering work, physicists began to test possible loopholes in their experiment. Ways in which the illusion of entanglement might be created. One loophole is especially hard to rule out. In modern Bell test experiments, devices at each side test whether the photons can pass through one of two filters that are randomly chosen, effectively asking one of two questions and checking how often the answers agree. After thousands of photons, if the results show more agreement than Einstein's physics predicts, the particles must be spookily entangled. But what if something had mysteriously influenced the equipment so that the choices of the filters were not truly random? It is this loophole that the team at the High Altitude Observatory in the Canary Islands is working to tackle. The team is creating a giant version of Clauser and Friedman's Bell test, with the entire universe as their lab bench. In this cosmic Bell test, the source of the entangled particles is about 1/3 of a mile from each of the detectors. The team must send perfectly timed pairs of photons through the air to each side. At the same time, the telescopes will collect light from two extremely far-off, extremely bright galaxies called quasars. These are among the brightest objects in the sky, emitting light in powerful jets. Random variations in this light will control which filters are used to measure the photon pairs. And since the quasars are so far away, the light has been traveling for billions of years to reach Earth. It makes it incredibly unlikely that anything could be influencing the random nature of the test. If the experiment is successful, the team will have tackled the loophole and shown that quantum entanglement is as spooky as Bohr always claimed. Dominic and Jason are at one telescope.
Hello, Anton.
Anton is at the other.
Good level. So we're doing everything at once now. So the guys for the links are setting the state of the entangled photon pair. We try to acquire the quasar. We're just centering it and making the field of view as small as possible to be sure that we only have the quasar.
Okay.
It's guiding now?
Yes, let's wait one more image.
Okay.
Of this one.
All right.
Great.
Yes.
Okay.
Yeah, that's good.
It looks like 90, let's say 91 to be conservative, of purity.
With the telescopes now locked on to two different quasars, the team begins to take readings.
Red counts 12,000, blue counts 7,000.
We do the full cosmic belt test.
It's working. Light from the quasars is selecting which filters are used to measure the entangled photons.
It is exciting. It is. Now we do have a test, but it's not clear what the outcome will be.
2 months later, back in Vienna, the team analyzes the experimental data.
This might take a second. The numbers look really great, and it is extremely pleasing to see that all this works so nice. We clearly see correlations that correspond to quantum mechanics.
Since the light from the quasars controlling the test was nearly 8 billion years old, it's extremely unlikely that anything could have affected its random nature. This remaining loophole seems to be closed. Accepting that entanglement is a part of the natural world around us has profound implications. It means we must accept that an action in one place can have an instant effect anywhere in the universe, as if there's no space between them. It was first seen as an unwelcome but unavoidable consequence of quantum mechanics. Now, after nearly a century of disputes and discoveries, spooky action at a distance is finally at the heart of modern physics. At the Institute for Advanced Study, where the concept of entanglement was first described, researchers are now using it in their search for a single unified theory of the universe, the holy grail of physics.
What we are learning these days is that we might have to give up that what Einstein holds sacred, namely space and time. So he was always thinking, well, we have little pieces of space and time, and out of this we build the whole universe. What's happening in space, in some sense, all described in terms of a screen outside here. The ultimate description of reality resides on this screen. Think of it as kind of quantum bits living on that screen. And this, like a movie projector, creates an illusion of the three-dimensional reality that I'm now experiencing. The most puzzling element of entanglement, that somehow 2 points in space can communicate, becomes less of a problem because space itself has disappeared. In the end, we just have this quantum mechanical world. There is no space anymore. And so in some sense, the paradoxes of entanglement, the EPR paradox, disappears into thin air.
The basic motivation is just to learn how nature works. What's really going on? Einstein said it very nicely. He's not interested in this detailed question or that detailed question. He just wanted to know what were God's thoughts when he created the world.
And there you have Einstein's quantum riddle. Maxwell and Shannon and Edwin Thompson Janes, 1865, 1948, then 1957, 59, and 63, expressed the notion of connectedness similarly, but not identically. Maxwell saw a kind of connectedness of electromagnetic kind that involved transfer of information at the speed of light, Shannon was dealing with a very abstract notion of information, which Edwin Thompson Jaynes reconnected with the material world. These two guys had slightly different views. Maxwell's equations showed a kind of connectedness that he described in terms of what he called Geisler's tubes. He said other so-called vacua, empty spaces, always had enough matter left capable of being set in motion and of transmitting that motion from one part to another. So this was the concept of radio waves traveling at the speed of light. Then we have Shannon's expression of a more abstract connectedness. He said the fundamental problem of communication, more specifically, the problem of reproducing at one point either exactly or approximately a message selected at another point, the connectedness has to do with that agreement that takes place in some cases and doesn't in others. In fact, that agreement can be the essential problem that is addressed in Zeilinger's experiment, if you followed that. Jaynes generalized the Shannon-type entropy to time-dependent irreversible processes, experiments, or experiential processes that can't be repeated. We can't go backwards in time. Where eventually all the information is lost. He generalized the argument from information theory to quantum electrodynamics, including in principle the Bose-Einstein condensation of an ideal gas. Now, the Bose-Einstein condensation, again, is still happening in space and time. It was a remarkable prediction, and it turned out to be true, but it also is not quite to the level of quantum entanglement. Here in this argument, I suggest that generalization of the notion of connectedness to quantum entanglement and how it results in the vanishing of matter, space, and time. It also demolishes distinction between locality and globality. It retains the distinction between the temporal realm and the eternal realm, that which is visible, passing away, versus that which is invisible and eternal. The abstract is not subject to decay the way the concrete world is. It suggests that the visible world was created from nothing by the invisible, omniscient, omnipotent, omnipresent God of the Judeo-Christian Bible, the Alpha and Omega of Revelation, the God of Abraham, Isaac, and Jacob of the Old Testament. It's grounded, I believe, in irrefutable, exact mathematical logic, refuting Einstein, Podolsky, and Rosen, and in accord with Zeilinger, Dick Graf, and others. Here is another way of looking at the process in constructing a TNR. I call this the flow-together diagram. I object, by the way, to the term entanglement because it suggests a kind of confusion, like the old-time false view of the human brain, as if all of its intricate connectedness were a scrambled bowl of spaghetti. In fact, it's so complicated and so intricately designed. Well, that's a story for another occasion. I've been thinking about this for a good while. It's the essence of what I call pragmatic information. It is so determinate, so connected, so completely general in its applicability to everything in this real universe, any multitude of multitudes of possible universes, to use a phrase or two from Charles Sanders Peirce. In his Harvard lectures of 1865, he described it as the unity of coherence. No one can deny there are representations, he said. We know representations absolutely, while we know forms and things only through representations. These are the representations of Peirce, these are the forms that Peirce is referring to, and these are the things that Peirce is referring to. We have the string of symbols, we have the valid pi mapping in TNRs, we have the perceptual representation, which happens to be correct in true narrative representations. I met this guy. He was, I've changed his picture a little bit here. I wanted to find a picture so you can see what he looked like when he was a young lad. He is since deceased. He went to Berkeley and built a program in mathematical logic. I met him when he was giving a lecture at the University of Rochester, where I was a graduate student, and he asked my professors, and I guess some of my colleagues in the program, who should I talk to about theoretical linguistics and logic and mathematics, and they said Aller. At the time I was constructing this argument, A Basic Circularity and Traditional Current Linguistic Theory, which was published in 1969, but I was meeting him in 1968, and after he gave his lecture, he calls me to his hotel in the middle of the night to talk about this argument. He asked me to submit to the journal he was editing, The Foundations of Language. Well, I did. He immediately rejected it, said, "This is no proof." A quarter of a century, I keep hearing the argument, no proof, no proof, no proof. I published the argument anyway. I thought it was a sound argument. And then in 1993, after a quarter of a century of trying to figure out what a mathematical proof really has to consist of, I came up with a proof. In 1996, I took on a more difficult problem. I'd been interested in Albert Einstein for a long time. He made a mistake, I thought, in trying to make everything in our ordinary experience come out the way it ought to if every eye blink and every movement of the body that seems to be under volitional control were actually under the determinate control of physical laws. I thought he'd made an error there, and so I wrote this paper about free will and why Heisenberg and Bohr had to be right and Einstein had to be incorrect about his search for a unified field theory. In 2010, I published The Antithesis of Entropy. Well, the antithesis is a TNR. Biosemiotic entropy, concluding the series. This was a paper with several proofs about true narrative representation. I was really riding on the shoulders of Bertrand Russell and Hans Reichenbach and Gottlob Frege to some extent. Frege said that truth was the basis for all meaning, but he didn't bother to prove it. Charles Sanders Peirce got around to developing a proof, and his follower Alfred Tarski produced some additional proofs, all of which come to essentially the same conclusions that I did, but I think my proofs are more intelligible than theirs. You can be the judge. TNRs in the concrete instances of actualized ordinary experience have approximately zero entropy. In their abstract form, they have none at all. Let the capital Greek eta, which looks like our capital H in the Roman alphabet, stand for entropy, which we can think of as a probability that any given representation may turn up false. If entropy is 1, well, then the proposition must be false. If it's 0, the proposition has to be true. We find the antithesis of entropy in valid pragmatic formation, which can be taken as the probability that any given representation will in fact be, or already is, true. In this series of inequalities, we start with 0 at the level of the TNR, the gold standard, has 0 entropy. And as we progress through fictions, errors, lies, nonsense to complete erasures, we come to an entropy of 100%, or 1. Shannon described this concept of entropy in terms of a constant. Pick any measurement unit that you like, and you have this relationship, the sum of the probabilities multiplied by that constant is always going to be a negative entity. That is to say, entropy tends to increase over time, and it takes away from whatever we define to be information, or the gold standard on the other side of this equation. Shannon and Weaver simplified the formula to this one, which they applied. We can drop out the k because it can be taken to be a unit number, 1 for example. Multiply 1 times any probability, you have the same result. The simplest example is the one defined in terms of 2 possible outcomes. Here's my explanation from 2014. Let eta represent the entropy of a set of probabilities p sub I through n. In the coin toss example represented by TNR, reporting the heads result, n is equal to exactly 2. In such a case, the probabilities can be represented such that p sub 1 is 1, the likelihood that the reported heads result is true, which it has to be if the report is a TNR, and p sub 2, the probability that it is false, is exactly 0, which it has to be if the reported result of heads is true. That is, the likelihood that the possibility of tails has been realized can be completely ruled out because that possibility is contrary to the TNR in hand. Shannon wrote, if all the probabilities but 1 are 0, this 1 having the value unity, as is the case for any TNR, eta vanishes. In the coin tossing example where n is equal to 2, before the result is known, eta is at a maximum. After the result is known, in this one or in any other TNR, the entropy value goes to exactly 0. Moreover, these results generalize to all possible representations. We find that TNRs have two distinct sides or aspects. They're demonstrated empirically in what the physicists have called quantum entanglement, or what I call the connectedness of TNRs. On the positive side, we find information going from 100% to 0. On the negative side, entropy going from 0 in a healthy person to 100% in a dead person. We notice that evolution and its directionality, according to the proofs of Peirce, Jaynes, Kolmogorov, Tarski, and yours truly, all of them go in this direction. Entropy tends to increase. On the positive side, what we're seeing is evidence of creation. In the beginning was the Word, and the Word was with God, and the Word was God. The same was in the beginning with God. All things were made by him, and without him was not anything made that was made. In him was life, and the life was the light of men. And the light shineth in the darkness, and the darkness comprehended it not. It's past tense when we talk about darkness, present tense when we talk about light. Light, goodness, grace, truth, mercy, all of it occurs in the present tense. Now is the time. Now is the day. Collins and I wrote a paper about the Bible as a true narrative representation. Then in 2013, based on the theory of true narratives and taking the Bible seriously as a true narrative, Collins and Scott reported on the discovery of the city of Sodom, the account of the discovery of the Old Testament's most infamous city. Then in 2021, Bunch down to Silva, a Tunguska-sized airburst destroyed Tel el-Hammam, a Middle Bronze Age city in the Jordan Valley near the Dead Sea, exactly where Sodom is supposed to have been, according to the Bible. Time's arrow is always flowing from the past into the future. Representations are connected, but we can only operate on them in the present tense. Even genetics can only operate in the present tense. From a God's eye perspective, these things are connected on both sides. It's kind of reminiscent of the DNA molecule that is separated in the middle where the translation is occurring. DNA is interpreted into RNA, and then the RNA is translated into protein. It isn't difficult to see that this diagram is incomplete. I've got an ellipsis here, and one clear over here. This would be extending towards the past, and this towards the future here in our conceptual thoughts. We anticipate the future, but we don't know what it's going to have for us in a material sense. If we had a more complete picture, we would see something that looks more like this diagram. My friend Jack Omdahl, a geneticist, suggested this completion of the diagram where we would connect the future to the material world much as we do the past. Let's say we're watching the movie and the stuff that's flickering on the screen is right here. What's in the future is over there. What's in the past of the film is over here. Now imagine you've seen the film before, or you're able to look ahead. Then you can kind of take the God's eye perspective, which gives us something very similar to Dick Groff's perspective. So we've got the material world in here, actions at risk, and you've got the abstract symbolic representations. This present time could be an instant, a second, a minute, an hour, a day, a week, a year, a century, or all of history. But from God's perspective, you could look ahead and see what's going to happen over here. I can't do that. You can't do that. But God can. Now, if you put yourself in the position of a film viewer, would you be causing the events to happen if you could look ahead in the film? The answer is no. Free will remains in spite of the fact that God knows what's going to happen over here, because we're over here doing our actions that to some extent determine what's going to happen in the future. For example, I can decide in the middle of this talk that I'm just going to take a sip of water, and I can stop and take a sip. free will overwhelms the physical forces that operate in here that were of such concern to Einstein. Now, but also in quantum phenomena and in representational phenomena, this instantaneous moment is unextended. Now, we can prove that mathematically. If it were extended towards the past, it wouldn't be present. If it were extended towards the future, it wouldn't be present. Therefore, this present moment, from that perspective, has to be instantaneous. So, God squeezes the whole universe to us. He presents it to us through an orifice that's a whole lot smaller than the eye of a needle. It's infinitely small. It is absolutely unextended, and that's where the quanta appear according to the recent results of Seilinger and colleagues. Well, this was interestingly commented on by none other than Bernard Riemann. This paper was published in 1873 on the hypotheses which lie at the basis of geometry. It appeared in Nature in 1873. It was written in 1854 by Bernard Riemann, the famous mathematician who died in 1866 at the age of 40. Dedekind published Riemann's paper, which was originally written in German, in 1868, 2 years after Riemann died, and Clifford got around to it in 1873. Riemann said definite portions of a manifoldness. Now, the four-dimensional manifold that Riemann defined, he defined all of those that exist between 0 and infinity, but the one that has 4 dimensions was the one that Einstein focused his attention on. Definite portions of a manifoldness, think of all of this area in here, this objective part of the material world projected on Dick Groff's screen. Definite portions of a manifoldness distinguished by a mark or a boundary are called quanta. Now, this is 1854. He's anticipating precisely the sort of thing that's going to be demonstrated later on in what will be called quantum entanglement after the big discussion that takes place in 1927 and then in 1935 involving Bohr and Einstein and all of those guys that we looked at earlier in this presentation. Another little bit that I want to go back to on page 1 of Riemann's paper, he says, the properties which distinguish space from other conceivably triply extended magnitudes are only to be deduced from experience. In other words, he said you got to do the kind of experiments that these guys, Seilinger and all these guys, are doing with quantum, what they call in quantum entanglement, what I prefer to call quantum connectedness, and I see that connectedness in this green area around here occurring at symbol speed in an instant. The whole universe is produced in this on this so-called Dick Groff screen. Skipping ahead, in Riemann's paper, cases can be defined in a discrete manifoldness. Now, this would be the kind that's quantized. I'll invent that verb. The declarations of experience are indeed not quite certain, but still not inaccurate. In other words, for any given flipping of a coin, I might make a wrong call, not looking closely enough and that sort of thing. But if I'm careful, my observation is not going to be inaccurate. There's no measurement error here. And in fact, we can reduce entropy to absolute zero in true narrative representations because of the connectedness which exists in the continuum. That would be in, this whole thing all the way around here, which is instantly connected at symbol speed, so that the discrete manifoldness is not inaccurate. But on the other hand, measurements of continua, of continuous manifoldness, every determination from experience remains always inaccurate. Now, there's the point where people want to retain some entropy in their formulas, and that's fine. Let's do that, but only for continuum. When we quantize things and we find their boundaries or their center, the entropy goes all the way to zero. paper by Riemann is so important, I've got to read just a little bit more on page 11. He says, "It is upon the exactness with which we follow phenomena into the infinitely small that our knowledge of their causal relations essentially depends." Now, that's where all of the fuss is going on about quantum entanglement. Because we are seeking to discover the causal relations by following the phenomena into great minuteness, so far as the microscope permits, questions about the measure relations of space in the infinitely small are not, therefore, superfluous questions. A little farther along. "Now it seems that the empirical notions on which the metrical determinations of space are founded, the notion of a solid body and of a ray of light, cease to be valid for the infinitely small. We are therefore quite at liberty to suppose that the metric relations of space in the infinitely small do not conform to the hypotheses of geometry, and we ought in fact to suppose it, if we can thereby obtain a simpler explanation of phenomena. Either, therefore, the reality which underlies space must form a discrete manifoldness, in other words, countable bounded objects, quanta, or we must seek the ground of its metric relations outside it, in the bounding forces which act upon it, in other words, the containing context, the continua which influence the discrete manifoldness manifested in quanta, things that we could find the boundaries of and therefore count or observe the relationships that exist between them. That space is an unbounded threefold manifoldness is an assumption which is developed by every conception of the outer world, according to which every instant the region of real perception is completed and the possible positions of a sought object are constructed, and which by these applications is forever confirming itself. The unboundedness of space possesses in this way a greater empirical certainty than any external experience. However, its infinite extent is by no means proved, because if it has a slightest curvature of a positive type, then no matter how small the curvature is, the space itself must remain finite. Setting that to one side, moving along to Charles Sanders Peirce and his existential graphs. Taking up one of the papers by Sowa on existential graphs from manuscript 514 by Charles Sanders Peirce, not the article I've got here on the screen, but a somewhat different one, nevertheless focused on the same content. On the second page, Sowa points out the correspondence between Peirce's logical symbology and that used by Peano, which became the standard in mathematical logic today. Peirce introduced two components that are critical to my TNR theory that I'm talking about here in relation to this Dick-Graph diagram. One was the existential quantifier. That would be the one applying to the world of experience that says what's actually out there. Interestingly, he called it a quantifier because in order to say what's there, there's a man, there's a donkey, there's a man who eats a man, to use one of Peirce's examples, a cannibal. To make any of those statements about objects in the world of experience, we have to quantize them. That is to say, we have to differentiate the man from the donkey, the man from the man that gets eaten, and so forth. And in order to do that, we have to use the existential quantifier that Peirce defined. On the other side of going from the concrete world to the abstract domain of symbols, we find what Peirce called the universal quantifier. It appears, according to Sowa, that Peano got his ideas from Schroeder and also from Charles Sanders Peirce. Schroeder got them from Peirce, and then Peano got them from Schroeder. At any rate, the existential quantifier pertains to this domain, and the universal quantifier pertains to the domain of symbols. And it's interesting that the universal quantifier is basically a symbol operating at symbol speed. Every single bit of Peirce's effort to explain in existential graphs what's taking place in here in the mapping of symbols onto quantized entities and objects, events, etc. in the material world. He said he was trying to turn thought inside out. His point was to try to make logic completely diagrammatic. But that's not the part that I want to emphasize. What I want to emphasize is that symbol speed guarantees that as soon as a symbol is used in a true narrative representation, all aspects of that symbol are as applicable instantaneously as possible to all of the objects in this entire realm, all the way around, and anywhere in the material world that you can find a man, the word man symbol already applies instantaneously, so that quantum entanglement is expressed in the connectedness of true narrative representations. And here we have the existential quantifier of Peirce, there we have the universal quantifier of Peirce, both of them acting in exactly the way anticipated by or explained by true narrative representation theory. We also have a complete resolution of the conflict between Dr. Einstein and the rest of those guys about quantum entanglement. Time, space, and matter all collapse into an instantaneous quantum phenomenon by which the whole material world is mapped onto this digraph screen.